So welcome to this. This is the Further Math Support Programme online revision session for AQA Statistics S2, and in this one we're building on S1 in the area of estimation. So how is this different than S1? Well, what we need to be able to do this time is we also need to be able to find confidence intervals of a normal distribution with unknown variance now, and we do this using something called a t-distribution rather than a normal distribution. So what are we given? Well, we're given a random sample of n observations is going to have, as we would expect from S1, has this particular form, other than, instead of having sigma as your for the basis of your standard error, we now have S, where S is the unbiased estimator. Okay, so it's fundamentally the same mathematics, it's just that we need to be very, very mindful now that instead of using the normal distribution table, we need to be using the t-distribution table. And notice very carefully that we have n-1 degrees of freedom. We have one fewer degree of freedom than we would if we were using the normal distribution. So here we go. Standard error x made in measuring a patient's temperature at a local doctor's may be modelled with the normal distribution. And we've got a mean and a variance of standard deviation of sigma. So the errors x degrees Celsius made in measuring the temperatures of 10 patients, so there's my value of n, is given below. So what they've done in this question is they've given you your summative for x, but instead of giving you the sum of x squared, they've given you the sum of the squared deviations instead, because sometimes that's easier to measure. Okay, so what we have to do is we have to construct a confidence interval, a 99% confidence interval. So the skills are very, very similar to what you would have found on S1, but we've got a little bit more work to do. So here, what do we know? Well, we know x bar is going to be the sum of x over n, which is okay, we can work that out, 0.35 divided by 10, that's 0.035, and s squared is the sum of the standard deviation squared over n minus 1. Okay, and you've really got to make sure that you're using n minus 1. Okay, so to do this, that's going to be 0.12705 divided by 9, which is going to give me 0.0141. Okay, and you're going to get a B mark for working out both of those. Okay, so for a 99% confidence interval, you can look that up in your t-table. Okay, you can look that up in your t-table to do this. So to do that, we are looking up t9 at 99%. Okay, and that's going to give you a value of 3.250. If you just look that up in your t-table for that, then that would be okay. Okay, here we go. Now, the reason I'm picking on this value is because, don't forget, it's two-tailed. So this is 99% two-tailed. Okay, so your T9 is 3.250. Okay, so that's my T value done. Everything else is now the same. It's going to be x bar plus and minus, I'll call it T9, 99% because it's two-tailed, times by s over root n. It's exactly the same formulation. So what's this going to give me? Well, it's going to give me 0.035 plus and minus 3.250 times by s, which we just worked out, is going to be the square root of 0.0141 divided by the square root of n. Again, if you use 9, that's bad. You need to make sure you do this correctly. So that's 0.035 plus and minus 0.1221. We do need to finish this off. So minus 0.087 to 0.157. Okay, now some people get a bit stressed about the fact this is negative, but don't forget x is an error, so it can be positive and negative. Okay, so there's nothing wrong with having a negative value in your confidence interval. So how is this marked? Well, we've established that we get a B1 mark for your x bar and s squared already. You get another B1 mark for getting your test statistic correct, your t critical value. We then get a method 1 and an accuracy 1 here. Method 1 for using exactly the correct form. Anything differing from that, you're going to not get that method mark, so you're going to lose the following 3 marks. And then an A mark for your final answer. Okay, so January 2011, question 1. Factory produces bottles of brown sauce and bottles of tomato sauce. The content Y is normally distributed with a mean of mu y and a variance of 4. So I'm writing that as 2 squared. A quality control inspection found that the mean contents Y bar grams of a random sample of 16 bottles was 450. Okay, and we're asked to construct a 95% confidence interval. So again, there's some work we need to do here. Now, rather nicely, we need to choose, okay, what we're going to do. So here we know the variance. We know they're normally distributed. Okay, so to do this, your confidence interval must be a normal distribution because we know your variance. Okay, so for a 95% confidence interval, what have we got? Well, we've got n is equal to 16. We've got sigma is equal to 2. We've got x bar, or y bar as it would be in this case, is equal to 450. So we can form our confidence interval. It's y bar plus or minus the critical value. Now it's normal, so that's 1.96. That's our normal, times by 2 over root 16. Okay, so that's going to give me 450 plus or minus 1.96 times by half, which is 449, all the way up to 451. Okay, so 3 marks. So you get a B mark for getting 1.96. You don't need to specifically state it, you just need it written down. You get a method mark for the rest of the formulation and an A mark for your correct confidence interval. So don't be caught out. Don't just go, oh, it's S2, it's going to be a t-test. As you can see, that's not always true. They need to check your understanding about whether you know when to use a t-test, a t-distribution. Okay, so content X grams of a bottle, we're now not given the variance. Okay, so here we've got a little bit more work to do. So quality control inspection found that the content is this. So it's practically the same question as before, isn't it? So we need your information. So n is equal to 9. Okay, the mean is going to be 4950 divided by 9. S squared is going to be 334 divided by 8. Don't forget it's n minus 1. Okay, so 41.75. And this one is going to be 550. So you get a B1 mark for working those out. Okay, so it's a 90% confidence interval this time. So let me go back. 90% confidence interval now is either of these two. Now remember, it's two-tailed, so it's this one that we're going to pick up on. Okay, and we are looking at n minus 1 is 8, so it's going to be 1.860. So here, what are we going to have? Well, we're going to have x bar plus and minus your test statistic 1.860 times by sigma, which is root 41.75, divided by root n, which is root 9. Okay, and then we calculate that through, and that's going to give me a confidence interval of 546 to 554. So again, you get B1 for working out your sample statistics. You're going to get B1 for using the correct confidence interval, test t-value here, M1 for the correct form, A1 for using all the right numbers in the correct form, and then an A1 follow through for the an A1 for the correct answer only. Okay, and then it follows on that there's going to be some interpretation. So Holly claims that the mean content of a bottle is 545, and we've got to comment on this claim. So let's look at the confidence interval of 546, 554 that we've just looked at. So what we can claim is that the confidence interval is wholly above 545. So what that leads us to do is to reject the claim. And the reason of that is because a confidence interval can be thought of as an acceptance region. So the CI is the acceptance region at 10%, because that's what it was in this particular case. Okay, so we can reject. So therefore, evidence is that mean is not 545. It's below what the confidence interval suggests, so that's what we need for that. Okay, so you're going to get a B1 mark for something that negates, anything that rejects as a claim, you're going to get a B1 mark. Okay, you're also then going to get an explainy mark, an E mark, for explaining what we've just done here, the fact that the confidence interval is your acceptance region, and then you get another B1 mark for stating that we're doing this at 10% because that's my confidence interval range.